Okay, hi everybody. Today we're going to talk about section 10.3 for our Math 8A Algebra 1 folks, and we're going to continue learning about radical stuff, square root stuff. So to start off today, let's break the ice with a little topic of the day here. Yesterday we learned that the square root of 3 times the square root of 5 does equal the square root of 15. You can take the 15 and break it into its smaller factors, into the square root of its smaller factors. Or you can take the smaller factors and combine them together and multiply them together to make the 15. What I want you to try to do is use your calculator to figure out, does this work with addition the way that it worked with multiplication? So would you please take a second, pause this video, use your calculator, and see if this works. Okay, what did you find out? Does the square root of 3 plus the square root of 4 equal the square root of 7? The answer is no, it doesn't work. This is false. The square root of 3 plus the square root of 4 does not equal the square root of 7. So you can't do this. Even though you can do this. And that's kind of the main idea behind today's lesson is, what about addition and subtraction with radicals? We understand multiplication with radicals. What about addition and subtraction with radicals? What could we do if we're trying to add and subtract radicals? We've seen that you can't just add them together. So we know that this is not going to equal the square root of 6. But what is it going to equal? That's what we're going to find out today. Now, I'm going to go ahead and answer the question and give you the main idea. By giving you an analogous problem or an analogy, if you have something and then you add the same thing to itself, what do you always have? You have double that thing. In other words, if you had 1 plus 1, what do you have? 2 ones. If you have 7 plus 7, what do you have? 2 sevens. If you have something plus something, you have 2 of that something. And that does work with addition, and it doesn't matter if the somethings are radicals, it still works. So what does this come out to? Well, if you have something plus something, you have 2 of that something. So you can combine radicals by addition and subtraction, but that only works if the two things are the same somethings. Because this doesn't work if you have two different things. You just have to leave it the way it is. So it only works if you have a radical 3 plus another radical 3. Could we have done that up here? No, because they're not something plus itself. So you only can combine radicals by addition and subtraction when it's the same radical. Now, when it is the same radical, it's really easy. So, for an example, what if I said, simplify this? 2 radical 5 plus 4 radical 5, or 2 times the square root of 5 plus 4 times the square root of 5. Well, if you have 2 of something and then you have 4 of the same thing, how many of that thing do you have? 6 of them. Easy. Super easy. Like, too easy. Could it possibly be this easy? Yeah, it is. And basically the way you want to think about this is think about this just as if this was 2x plus 4x. It'd be 6x. Think of those radicals kind of the way that you think of variables in this context. Again, it only works on this problem because these match. If this had been 2 radical 5 plus 4 radical 6, you can't do anything with that. Okay, easy enough. What about if we step it up one more little tiny notch? What if I had 2 radical 5 minus 7 radical 5 minus 5 radical 5? What would that come out to? Well, it would be just like if you had 2x minus 7x minus 5x. How many x's would that be? 2 minus 7, negative 5, negative 10x, right? So what's this? Not negative 10x, negative 10 radical 5. And that would be your answer. Yeah, it's as easy as that. Let's just practice a few more to make sure we got the hang of this. Simplify. How about 2 times the square root of 45 plus 4 times the square root of... Uh-oh, they don't match. What are we going to do? Well, in this case, we can't combine them as is, but I know something about 45. It's 9 times 5, isn't it? And I know something about 20. It's 4 times 5, isn't it? So this is really 2 times the square root of 9 times the square root of 5 plus 4 times the square root of 4 times the square root of 5. And what's the square root of 9? 3. So this is really 2 times 3 radical 5 plus 4 times 2 radical 5. And what do you know? We have 6 radical 5 plus 8 radical 5, and I can now combine them together. So even though I didn't have matching radicals to begin with, I do have matching radicals in the end. And that thing boils down to a nice, concise, and simple answer. Simplify things and then see if you have any like radicals. Okay, how about this one? 5 radical 19 plus 4 radical 28 minus 8 radical 19 plus the square root of 63. Ooh, why don't you pause the video right now, try that on your own, and see what you come up with. Okay, here's how I'm going to do this. I can't take the 19 and break it down into anything, so this 5 radical 19 is going to stay a 5 radical 19. But I can combine that with this, and that's going to give me negative 3 radical 19. Now I just have to account for the other parts. So what about 4 radical 28? Well, that's going to be 4, and then how can I break the 28? 4 and 7? And then what about 63? By the way, that was a plus here. 63 is 9 and 7. So this is going to be 4 times 2 times the square root of 7. This is going to be 3 times the square root of 7. And what do you know? I've got common radicals, and 8 of them plus 3 of them is going to give me 11 radical 7. But don't forget, we had that in there as well. How many of you got that? If you did, you're doing great. And we can't go any further because you can't simplify those and they can't combine. So that is the answer to that problem. Okay, what if we've got some parentheses in the mix? What if I'm going to ask you to simplify this? The square root of 6 times the square root of 10 plus the square root of 15. Well, whenever you've got parentheses like this, your gut instinct should be distribute. And you're right, you should distribute. So I could combine these and make it radical 60. But rather than combining them together, don't I want this broken down anyways? Because I'm just going to break this down even further, right? So you might as well not make it into a 60. You might as well keep it broken down. And then what do we notice here? We're looking for, what are we looking for? Based on yesterday's lesson, we're looking for squares or pairs? Do we have squares? No. Do we have pairs? Yes. So I'm going to have 2 radical 15 here. Yeah? Everybody okay with that? And then for my second part, I've got to do radical 6 times radical 15 with a plus in the middle. This is 2, 3, 3, 5. So I'm looking for squares and pairs. I don't have any squares, but I do have a pair of 3s here. So I'm going to have a 3 in front and a 10 stuck inside, right? Because the 2 and the 5. And what was in the middle of it all? A plus. And that would be my answer to that problem. And kind of like factoring, don't stop until you can't factor anymore. Don't stop until you can't simplify anymore. So it's always good to double check. Can I break the 15 down? Well, 3 and 5, but that's not going anywhere. 2 and 5, yeah, that's not going anywhere. This is as simple as this can get. What if there are 2 sets of parentheses? Like, you want to give it a try? Give it a try. Come on, pause the video, give it a try. All right, so the 2 sets of parentheses just means we get to have more fun because there's more to do. So this is going to be like FOIL or double distribute 10 and 30. Again, I'm just going to keep it as 10 times 30. And then that's a minus 10 and 18. And then I'm going to do this one, 6 and 30. And then I'm going to do this one, that's a minus. And now I've just got to go piece by piece, problem by problem, break it down, see what I've got, find some pairs, find some squares. And let's see. I'm actually not going to break the 10 down because I already see on this one that I've got a 3 and a 10 and I have a pair there. Does that make sense? You could have broken it all down and find squares and pairs there, but this is going to end up being 10 radical 3. This one over here, let's see, what do I notice? 10 and 18. I guess I'm just going to break it all the way down. 2 times 5 times, 9 and 2. That's good because 9 is a square. Oh, I've got squares and pairs on this one. So I've got a 2 and a 2, so it's going to be a 2. I've got a 9, which comes out as a 3, and then all I've got left in here is a 5. So this is going to be 6 radical 5. And this was a minus, right? So it's 10 radical 3 minus 6 radical 5. What have I got over here? 30 is 6 times 5. So I've got 6 and 6 and 5. So that's going to come out as 6 radical 5. And that was a plus. 18 is 6 and 3. So I got my pair. And that's a minus 6 radical 3. So now I've got 10 radical 3 minus 6 radical 5 plus 6 radical 5 minus 6 radical 3. And what do I have in common? Well, the radical 3 parts match. So if I have 10 of them and I take away 6 of them, I have 4 of those, 4 radical 3s. And then the radical 5s match, but there's negative 6 of them, plus 6 of them, and those end up just scratching each other out. And this whole thing boils down to 4 radical 3. If you got that right on your own without watching me do it, then you are awesome. Good job. Hopefully watching me do it made sense if you needed to see me do it. We've just got one more practice problem, and then we're out of here today. And today's last practice problem is the square root of 50 plus the square root of 32 minus the square root of 1/2. Yay! A fraction. All right. Let's not worry about the fraction yet. Let's just do it piece by piece. 50 is easy. It's 25 and 2, right? So that's 5 radical 2. 32 is not too bad because it's 16 times 2. So that's 4 radical 2. But what's going to happen over here? Well, remember, we've got to take this and we got to do the square root of 1 over the square root of 2. This is 1 over radical 2. What am I going to do with that? I can't leave it the way it is. I've got to rationalize that denominator because you're not allowed to divide by any irrational number in math. It's against the rules. It's illegal. So this is going to end up being 1 times radical 2 on the top. Radical 2 times radical 2 on the bottom, which is radical 4, which is 2. So notice I now have 5 radical 2 plus 4 radical 2 minus radical 2 over 2, which isn't that kind of like a half of a radical 2? So if I have 9 radical 2's and I take away half of a radical 2, I guess I could say I have 8.5 radical 2? That's a weird way to write that, and I don't think I like that very good. So let's instead do it this way. Let's make this 10 radical 2 over 2. Let's make this 8 radical 2 over 2. Let's make that 1 radical 2 over 2. And I have 18 minus 1. I have 17 radical 2 over 2. That's probably the best way to write that. And isn't 17 divided by 2 8.5? Yeah. So I could have written like 8.5 radical 2 or 8.5 radical 2, but I think this is better because it's weird to mix decimals and fractions with root expressions, and that's probably the best way to write our solution to this problem. All right, if that makes sense, you're in good shape. Hopefully you were able to follow along. You know, when you're watching these videos, feel free to pause, rewind, jot down any notes, any questions. You can always contact me if you need extra help. But assuming that everything makes sense and looks good here, you're ready to do a little practice. Today's assignment for section 10.3 is to do page 637, numbers 13 through 30. Hopefully you've all got your books or you're accessing the online textbook. If you're having any technical difficulties with that, just let me know. Otherwise, I'm going to assume you're in good shape. Love you guys, miss you guys. Hope you're doing well. See you next time.